Hey everybody, welcome to Houdini Hangout. Hope you're having a great day. We're here in the middle of March, and locally for me, things are warming up or kind of a little bit bipolar around here. Temperatures going up and down like crazy. Um, but yeah, we're starting to get out of the dead of winter, which is nice. Starting to see my grass out front, and yeah, things are good. So hope you're having a great day. My name is Peter. I'm the host of the stream, and yeah, today we're going to be taking a look at doing a little Mardini entry. I mean, it won't be a very good one, probably won't be rendered or anything like that, but I'll screw around, get something going, and make something with what we have, with the time we have. Normally, when I had done Mardini in the past, I think for me it pretty much went every night until probably 11:30. So yeah, it was. If you are a part of the fun, then I'm sure you've had plenty late evening. So yeah, I was also doing it when I was working, so I'd work all day and then come home and do that all night. So it was a pretty crazy month. Anyways, yeah. So tonight we are going to do the Mardini prompt for the day, which is, let's see here. Sorry. The prompt for today is crawl. It's the week is kin effects, kin effects week, and yeah. So crawl. So I think I know what I want to do. I think I'm gonna do just a little like robot, like crawly little robot, and make him like a little character, or I don't know, something like that. Hadn't really thought of it beyond that, but we'll see what we get up to. So that's my idea. That's what we're looking at here. One little shout out I wanted to make was, if we go back here, this place number one is Zach Katara. Yeah, Zach Katara. Whoa, that was weird. I had some weird flickering going on there. Sorry about that. And he's active on our Discord server, so that's pretty cool. So congrats to Zach. And yeah, so that's I don't know if that's your name, Zach, but whatever. That's your screen name. So so congrats on that one. That's pretty exciting. I can't search how to animate cube in Houdini. Yes, that's a good one. How to animate cube in Houdini is a good one. Yeah, that one's amazing. He did the I don't know how to pronounce his name. It's like Zap, something with an X. I don't know. Anyways, he did some presentations and stuff like that. Actually won a thing in Europe that one of my coworkers went to, and he said it was really good. They were doing like, I want to say they were doing like bingo, but it was in Houdini, and it was all these different weird simulations and stuff like that. It was really crazy. Anyways, yeah, it's a good one. It's a classic. So yeah, so we're going to do that this evening. And yeah, there was something else I wanted to. Oh, Zarkanen. Yeah. Anatoly. I see Anatoly. Yes, there we go. Thank you, Tom. Oh, he's a senior TD at DNEC. I did not know that. Cool. So anyways, yeah, that's what we're going to get up to, or something like that. Yeah. That's what we're going to get up to tonight. We'll see what we can do. I feel like there was something else I was going to say, but we'll get to that eventually. I'm sure I'll remember at some point. But Cool. Well, that's about it. Hey, look at that. I don't often look over and see a follower thing like that underneath wherever here, but someone's following. So cool. Thanks for following. Oh yeah, Tom's saying it was in Utrecht with pipes and balls rolling into the pipes and RBD sim. Yeah. Yes, that's right. It was yeah, it was like I guess it would be like a bingo type thing or something like that. Yeah. Pretty fun. Cool. Well, great. If you guys have any thoughts or questions or comments or anything like that, as we go along through, through what we're screwing around with this evening, feel free to drop it in the chat. There's no dumb questions here. There is no, at least Houdini related. If you have a question, most likely somebody else does as well. So, feel free to ask that, and it will be a help to more than just you, but to other folks that might be watching. So, hey, George, nice to have you on the stream. Welcome. There was another thing at the top of the chat that I saw that says, "How was the GDC presentation?" I'm not sure. I'm assuming it went well. All I saw was a picture of Mai, who's the head of labs, doing a presentation at GDC. So I'm assuming it was great. Mai is a great guy and super smart, and probably was up to some fun shenanigans. So, showing off something cool. So, I'm sure it went quite well. Let me just make sure I'm all muted and some things aren't blowing up my phone or watch or whatnot. So sorry. I feel like I'm a little out of sorts today for some reason. So there we go. Great. All right. Are they live streaming them? No, they're not live streaming the presentations that I know of. In fact, I'm not even GDC's I feel like really stingy with having anything available after the fact. So, at least that I've ever found, I've never seen it streamed. Like, I feel like with SIGGRAPH, it's easy to find if they're streaming and stuff. So, yeah, exactly. Yeah, no, Side Effects doesn't really ever live stream stuff personally. So, cool. I'm just seeing a couple other chats. Vink Real. Hey, I just discovered. Yeah, welcome. Glad to have you on the stream. And Scripty is asking if I'll be attending EPC this year. No, nobody on my part of the education team is going to be at EPC this year. Obviously the marketing folks will be there, and probably people from the real-time side of our company will be there, but not me this year. I will be at FMX, but not at EPC. So anyways, cool. Well, let's jump in. Let's do some Houdini. So what I was thinking of doing was, like I said, just a really simple little robot, probably nothing too crazy, but we'll mess around with some, rigging, a little bit of, maybe try to even do some procedural animation. That one, I'm a little unsure of how we're going to exactly do it, but we're going to give it a shot. So, that's usually most of my streams is I'm kind of unsure of how this is going to work, but we'll give it a shot. So let's just make a little like boxy robot, 4 little legs, make some joints for him and stuff like that. And, we'll start making a little something that'll be able to, animate and move around and stuff like that. So, all right, yeah, let's do it. So let's drop a geo node down, and we'll just call this geo simple robot, because it's going to be a super simple robot. I'm not going to be doing any crazy modeling or anything like that. How to melt with flip. So if you're looking for help with stuff like that, Entity, and I guess this is a good enough place to plug that. There is a Discord server, so if you're looking for something that's a little like that, like slightly off topic, that would be a great place to ask that. Lots of people have been there, so I actually think just recently we got over 1,000 people that are in that Discord server, which is crazy. I don't even understand that, but that's cool. So there's a lot of people there, super helpful, friendly people. So that's always a place where you could go and ask some questions. There's a free invite on HoudiniHangout.com, so you can just jump in there and join up. The one thing I will say is like, and this is kind of just a little side topic, is that if you're coming into any like public kind of forum type thing, Discord, whatever, Slack, things like that, I think the best thing to do if you're asking a question like, how to melt with flip, or how do I make this explode or fracture or whatever, I think the best way to go about that is to like try and come up with something that you have. And then if you're struggling with something, you can say, hey, here's what I tried, but it doesn't seem like it's working. What do I do to make this better or work or something like that? And I think that's a much easier way for somebody to be able to help you out than like saying like, because you can search tutorials on just about anything these days for Houdini and find it. So anyways, just a little tip for anybody that might be asking for help or whatever. Just something I've noticed, and people are a lot more eager to help if you kind of take the first few steps yourself and then go from there. So anyways, Shooting Blind, hi. Yeah, I'm doing well. I'm a little tired today. It's been a long day. So, but other than that, yeah, good. Everything's good. All right, so we're going to make a simple robot. So I'm just going to make him with like a cube, some spheres for joints, cubes for legs, nothing crazy. We're just going to make a little robot and see if we can make him crawl and animate and do something like that. So let's give it a shot. So, all right, so let's do this. We'll just drop a box down here, and we're going to just kind of make a little procedural robot guy. So maybe in the Y we'll do 0.25 Houdini time. Got a little cyclone. Yeah, that's right. We probably don't have the Houdini icon. Yeah, you can't do the Houdini icon. All right, so let's do this. Yeah, maybe 0.25. Maybe in the x-axis we'll bring it down a little bit to like 0.5. Actually, maybe this will be a little thinner like that. Just kind of make like a flat little walker type thing. Cool. So let's do that. Super exciting so far. Let's also take, so what I'm going to do is I want to make a way to kind of procedurally set this whole thing up. So I'm going to want to make the skeleton like procedurally. And so what I'm going to do is I'm going to copy some lines onto spots where I want the legs to be. And then I'll use that, points and lines are that's all you need for a skeleton, right? And so, so we'll do that and then kind of go from there. So what I'm going to do is I'm going to get some points that are going to kind of sit along the, if you want to think of it as like the equator of it, kind of the middle point of this horizontal part of this, kind of rectangle, this cube. So what I'm going to do is I'm going to grab a grid, and I'm just going to take this down to 2 by 2 rows. And so what we can do then is we can do a match size with this. A lot of times I'll use this to like center things, but in this case, if we wire in our grid into the first input and then the second input into the match size and say scale to fit, and then uncheck uniform scale, this is going to actually take our grid and scale it right to the size of this box that we have, right? Because it's actually going to be going by the bounds of that geometry. So now in this case, we actually have 4 points, right? So we're kind of getting part of the way there. The other thing I'm going to do is I'm going to do a transform, and I'm going to scale it down just a little bit in the Z axis here. Actually, I'm going to change this. There's a guide. I'm going to set this to like 2. Because I think that's going to actually be easier for people to see. I kind of forgot to do that. I'm just going to save that as my default. There we go. Now you can see my z-axis maybe a little better. So we're going to go along the z-axis and scale this down a little. So maybe we'll just scale it down by like 0.9. Sure. That looks good. Okay, so in this case, these are going to be the points that we're going to copy onto, right? And what I want to do is I need to get the normal direction for these points. So what I was thinking about was I could do an orientation along curve with this. And from there, I could try to get a better normal direction here, right? Hey, Zach, welcome to the stream. Nice to have you. Nice to have you. And so here we have normal directions that we're getting based on our geometry. And so what I'm going to do is I'm going to uncheck these and turn this one on and use the out direction. And we can... Oh, you can't... you can't see the the nomen, right? That's so funny. I never thought of that. And I can't move it. Okay, well, there you go. I mean, I could make it huge. Let's see. Now you can see it. Sorry, just being stupid. Oh, that's silly. Yeah, sorry. I'll have to think about that. Never really thought about that before, that this is covered. Anyways, yeah. Anyway, so what we're going to do, yeah, that is funny though. I hadn't thought of that. Been doing this for 3 years now. Hadn't thought about the fact that nobody could see that this whole time. If you guys ever have any suggestions for like better layouts or things like that for the stream, I'm always like, I'm all ears. Like if there's a better way I could line this stuff all up. I try to do it so that I get the most content on screen with me blocking hopefully as little as possible. But you know, if you guys have suggestions for better ways to lay it out or whatever, I'm all ears. There's a spot on the Slack channel that I think has had 2 suggestions ever. So, eye opener. Yeah, exactly. Shows how much I pay attention to even what I'm doing. Anyways, so yeah, so we've got these normals that we're going to use here, and they're not pointing in exactly the right direction, right? Because when you're copying the points, the Z direction of whatever object you're copying will point down. Yeah, it's probably not a big deal. You're right. The Z direction will point down whatever normal direction you have. So if we were to take something like a line in this case, we'll make it with 3 points and maybe, I'm going to say a little longer, like 0.125. We'll see. If we take this and we do a copy to points and then copy these in, well, right now it's on the y-axis, but if we go along the z-axis like this, you'll see that it points. So yeah, so our line is pointing along the z-axis, and now the legs are kind of going out towards, excuse me, towards that normal direction. So what I'm going to do is I am going to, although that is kind of interesting, I wonder what would happen if we did more rows. Yeah, that's interesting too. Anyways, okay. I might want to mess around with this later, so we'll see. Anyways, let's do this. So let's straighten these out so that they're coming out from the side of the robot. So what we can do is we can just use a really simple attribute adjust vector, like so. And we can adjust the normal. And in this case, if we look, we can just go like this and look at it. So we're going to adjust the normal attribute. And what we can do is we can multiply the normal we can basically multiply the Z component of this vector by 0. Because right now we have this, 0.7 in each of these. If we multiply, this changes from add to multiply. Right now it's at 0, so it's multiplying everything by 0. But if we multiply each of the x and y by 1, and then the last, the z value by 0, now we have normals that are pointing out to the side. So we're kind of procedurally getting those values, right? And so let me turn this down because that's fine. Okay. Anyways, so now we've got lines that are pointing out to the side like this, and that's looking pretty good. I actually think this might be a little too long, so I am going to shorten that down a little bit. Maybe even more like that. Cool. So there's our little character that we're going to be rigging. So one thing I'm going to do is I'm going to just do this. Let's see. I'm going to pack. So what we're going to do is we're going to use a capture packed eventually here to get these objects. So what I'm going to do is I'm going to pack this geometry here. Like so. And we're not going to pack this because this we're going to copy some geometry onto, but this will pack some geometry, or we'll pack onto. And then I'll put a name here because each of these are going to need a name. And so this I'm going to just call, I guess we could call this the body or the root. Yeah, let's just call it, we'll call it body. That's easy enough. So this, and we'll put this on the point instead of the primitive. There we go, body. So let's come down here. We've got our body right there. Let's mess with this a little bit. So what we're going to need is, let's do a sphere for each of the joints. And so let's do this. Let's do a polygon, and let's do a copy to points again. So we're doing a copy to points twice here, and that's way too big. That's okay. We'll scale this down. So I don't know, 0.1. How's that look? Yeah, that looks fine. Looks like a decent scale. I'm going to turn off the point visualization and just up this a little bit more. And I am actually going to pack these. So we'll just pack those all. So we've got our joints here. And what we need to do is, well, let's now take these lines and let's actually get a box, more boxes kind of on that. And we can get that working. So again, we'll turn the points back on. And so we have each of these primitives. So let's do this. Let's do a convert line, and using the convert line, we'll actually change this so that, it'll give us a rest length, which will be actually kind of helpful because we know how long to make these boxes. But what it'll also do is convert each of these from one primitive to a primitive for each segment. So if we had these with, 3, we'd have a segment, or we'd have a primitive in each of these segments. So there's a convert line. And if we take that now and do an extract centroid from that, and use run over primitives, we're going to get a centroid for each of those. And now we can use that to copy some boxes onto. So if we do a box and a copy to points, like so, and make this way smaller. Let's see. And 0.1, maybe something like that just to start. And what size are these? Yep. So let's take this down. We'll do this 0.05, something like that. So they're a little thinner. And we want them along the z-axis, right? Because that's where our normal direction was pointing. So let's see if we can't get these normals to be copied over. So we didn't copy the normal here. So let's just add one in. We can just grab the normal, and that'll copy those over to the points. So now we have normals. If we convert these to lines and extract the centroid, yes, we would also need to promote those. So we'll promote those to the primitives. So let's do this. Let's do an attribute promote. And so we have the normal on the points. We want to get the normal onto the primitives. And so we'll do that. Now we have our normal on our primitives. We do the extract centroid, and we can actually transfer attributes like the normal. And there you go. Now we have that normal on those points. So when we copy these, we will actually have the normal, have these pointing in the normal direction down the z-axis. Just a little easier to control, since so we'll have them all sort of set the same. So let's do that. And then the other thing that would be good is let's actually set this, let's set the length of that box to be the rest length that we're getting up here. So what we could do here is just do, yeah, let's do an attribute promote just to make this maybe a little cleaner. You don't have to do this. You could kind of pull it from one of the primitives or whatever. But I'm just going to make this a little cleaner and just give this a, okay, this is on the primitive. And we're going to grab the rest length and put that to a detail attribute. So now we have the detail attribute there. And we should, yeah, we'll just make a null here that we can point at. And we'll just call this rest for now, like that. Great. And so what I'm going to do is I'm just going to point the length, the Z axis of this box to that rest val null just to be able to get that kind of procedurally so we're not just setting it hard coded. So let's do this. Alt E, make this a little bigger. And let's do detail. Oh, right. I'm like, why is that not coming up? Used the wrong one. Detail. So then we're going to get the surface node, which is just going to be rest value. And then we're going to get the attribute name, which is going to be rest length, like so. And then the attribute index is just the 0th attribute, so nothing too crazy to worry about there. Then we can hit apply. What did I do here? Syntax error. What did I syntax error? What is my syntax error there? Oh, I don't need the backticks? Right, because that's a string attribute. Thanks, Tom. That's if I needed a string. Thank you. Not thinking straight. There we go. Yeah, it's a float parameter, right? Yeah, if I was a string parameter, I needed that. I feel like I do a lot of string parameters like that, so it was just kind of a, yeah, anyways. Dumb. Okay, let's continue. So we've got that. We've got these copied over. The only thing I'm going to do is just scale them down a little bit. Well, that probably wouldn't really matter too much here. Yeah, I'll just to be a little more clean, I'll just do a transform here. In the scale it in the X, 0.9, just something like that. Yeah, it's probably a little cleaner to do it that way. And we're going to pack and instance that. These are also packed and instanced. Great. Cool. Okay. So that'll be $600. Wow. Tom, trying to shake me down for money. Wow. That is a steep consulting fee. How about I just let you come and hang out in Buffalo some point? How about that? Well, that'll be our payment. All right. I can pay 56 installments. Okay, so let's start merging these together here. Oh, pulled one too many there. Shift. There we go. And we'll also get the body here. Cool. Got some legs. All right. So I think that's enough. We don't have to go too crazy with this little guy. I mean, I could make a head and all sorts of other things, but we'll just make some legs, see if we can get them animated and working and going like doing some interesting things. So if you're familiar at all with how kinefx works, if we need to do weighting on a skeleton, well, first of all, we need our skeleton. We need to make our skeleton, so that'll be part of it. But the things that make up a skeleton are having names on the points and transforms on the points. So the transforms are pretty easy to work with, not too hard to make that, make that work. The thing that's a little trickier is we want to match up the names of each of these pieces and get some sort of logical hierarchy to the names. Give the leg number and maybe the joint number that each of these belong to. So yeah, let's do that. Let's take our skeleton and start to give it some names or give the points some names. And what we can do to actually make this a little bit easier for us is we can name give some of these attributes before they're actually, instanced and things like that. So in this case, we have our grid here with our points, right? And we've got our match size and our transform and things like that. What we could actually do with that is we could add an attribute here that will allow for us to actually give each of these a number. Now the copy to points doesn't have like a number that we can pull from it. I think the duplicate node does, which is kind of interesting. Kind of curious. I just realized that. I was like, that's kind of interesting. But, all right, so let's do this. There we go. Let's do an enumerate, and we'll drop this down, and this will just give us, we'll call this one leg. We'll make an integer, put this over the points. And now we should have a leg attribute that gets copied down through this, and each of these points will have a leg attribute down here. So with that in mind, we have now a point attribute that can tell us which leg we're working with here, whether it's 0, 1, 2, or 3. We could also add 1 to that or something, add a value into that to make it start at 1, but to me it doesn't really matter right now. You can always play around with that later. Here now we can do the same thing with enumerate, and each of these can represent one of our joints. So we'll call this one joint. It'll be an integer. It'll also be on the points. So now if we look at this here, we have leg 0, joint 0, 1, 2. Leg 1, 0, 1, 2. So now we have these kind of points that are these attributes that will describe which leg and which joint on that leg we're looking at. So now what we can do is we can take this copy to points. We can actually just pull off pull this off over here. And we can also maybe grab this. We'll merge those together. And this is going to be kind of where we start to build our skeleton. And so with this, what we're going to want to do is we're going to want to probably do an extract. Just do an extract all points here. And that'll just give us our main center point there. This already has a name on it. So we'll do that. And then on this other path, or this other wire here, we'll just do a simple point wrangle. So let's do that. Let's do a point wrangle. Drop that down. And here, what we can do is we can say, we can just build a string value. So we can do s at name. So it's going to be our string value for our string attribute for our name. And let's just take, we can just make sure that this is working by just say I at joint, oh, sorry, not equals, plus I at, well, actually, we'll do it the other way. We'll do leg first. Leg joint. Yeah, that seems right. We'll do I at leg plus I at joint. Now, these are just integers, so we need to convert them. So we'll do I to A, like so. And that takes an integer and converts it to a string. Okay. And then I'm also going to put in a, we can just do an underscore between them for right now. And I need a semicolon at the end. There we go. So now, right now, we just have the name 00, 01, 02, blah, blah, blah. Great. So that's doing what we want it to. So let's adjust this a little bit more and say, put in quotes here, leg, and then add I to A. Let's just make this a little bigger so we can see the whole parameter here. So we'll do leg, with the integer, the leg integer, and then we'll do underscore joint plus the integer there. Hit accept. So there we go. We got leg 0, joint 0, leg 0, joint 1, leg 0, joint 2, blah, 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 all the way down. And what we want to do then is we want to connect these in the middle here. So what we can do is we can just do connect adjacent pieces. We should be able to do... Oh, sorry. What? Oh, right. So we can do this and just find it like so. Maybe 0.55. And then if we up the number of maximum connections, it'll allow those to be connected in the middle like that. There we go. All right. So that is going to make our skeleton basically. And we should have names on each of these. Now this is just the skeleton geometry. It's not really, built into, it doesn't have all the kind of kineffect stuff that goes along with that. But it is kind of starting along in that process. And we can then start to, we can add the actual attributes that'll create this, turn this into a kineffect skeleton properly and go from there. So, all right, let's make some some nulls here that we can use. We'll just say null here. Not sure if we'll need to do anything with this. Yes, I do know one thing we'll need to do. We need to get the name attributes here so that we can match those together. So let's say out geo for that. And then we'll do a null here. Say out scal. And hello. I think the easiest way to do this is, since we have our skeleton right here, right, that basically has all of our point names, we can just attribute transfer those over. So let's do an attribute transfer. Wait a second, what is that? Oh, I thought there was another attribute transfer that I never saw before. Okay, so let's wire those together like that. Cool. And let's turn off primitives. We can just do the point names. And now we should have names for the closest joint for each of these. And conveniently, when we're doing this, because this point is in the middle, it is actually grabbing the lowest point number, it seems like, because it's kind of equidistance between these 2 points. So it is being bound to this joint here, which is what you want. You don't want it to be bound to the next joint, the child joint down the line, because we're doing all just rigid transforms with these. Oh, sorry, Zach, I just saw your question there. Do the new lines from connect adjacent pieces have no names? They do have names, because what they're doing is they're keeping the names from those points. The name attribute is on the point, so it stays. If it was on the primitives, it would get a little, or on the points, it would get a little messed up. But because it's on the primitives, it's fine. Sorry, switch that. I think I just totally flipped that around. The attribute lives on the points. If it lived on the primitives, that would be a different story. But because it's on the points, it stays when it builds the new primitive. So yes, there you go. So yeah, they stick around. Now, this needs to actually be adjusted a little bit. And actually, what I'm going to do is I'm going to do an attribute delete here, because I don't actually need those joint and leg attributes. So we'll just get rid of those. And I am going to take this name and I'm going to promote it to the primitives. Because when we're doing the capturing, it's going to be looking at the primitive name attributes, not the point name attributes. So we're going to do point to primitive, and we'll do name, and we'll move those over to this, over to the primitive level. We have all the same number of each of these, so it doesn't really matter. They match up 1-to-1 with packed geometry. So moving the name over like that is fine. So, okay, so we have our geometry that's output here, and we have our skeleton that we're going to use to bind to that. Cool. So, great. I think we have our little silly little robot kind of made up here. Now, the fun thing about this is that if we do increase the number of legs with this, all of this stuff should be completely procedural. Oh, that's not. Whoa, didn't think about that. Huh. I'll have to think about how that, because that's not working right. That is going to need, oh, hold on a second here. Is this? No. Oh, actually, you know what? I might be able to use this still. Let's see. Leg is the cluster attribute. Can I use that? Primitive attribute. Okay, let's just try one thing here. Sorry, just going to see if this works here. No. All right. Well, for right now, we won't worry too much about that. That's interesting because it should work except for that one little bit there, but that's okay. We will get back to that. Probably the best way of doing that would be, what did I do? What did I do? Oh, right. Yes. Why am I getting an error there? Getting an error there. I'm not sure why. Anyways, yeah, exactly. The worst feeling when it should be procedural and breaks. Yeah, I should have just made a bit more of a robust thing there, which is easy enough to do. I could just set a group to be with the roots of each of those, like the kind of origin point for each of those lines, and then just make new ones with Vex or something. Be pretty easy to do. But for right now, there's no reason to worry too much about that because we got to rig this thing first before we add anything like that to it. So, or, get it working. So, we have this all good, I think. Yeah, I think we should be good. We can always come back, obviously. All right, so there's that. Turn that on. Let's do another geometry container, and this will say rig simple robot. That's not how you spell robot. And let's do that in, I don't know, blue. Let's do a couple object merges to bring in the geometry that we'd made. We'll say get robot geo. And this is going to be our out geo. And then we can grab our skeleton as well. Great. So there we go. We've got our, I'm going to hide the other objects and we'll just maybe wireframe that. So now we have our skeleton and our geometry that are in our network here. And what I'm going to do now, these should all be packed. Yep. So what I'm going to do is I'm going to use a node called capture pack geometry. And this is a little different than some of the other captures, right? So if we do capture, joint capture proximity, for example, this has our three kind of streams of data going through it, right? This one's a little different. It only has 2. And so this one only needs the skin geometry and the skeleton. Now, technically, this one would only need the rest and the capture pose. But this is only going to output the capture geometry for us to use. So in this case, what we're going to do is we're going to put our skin geometry into the first input and the skeleton into the second. And the skin geometry is better, or in this case, because we're capturing packed geometry, it's best to have it packed ahead of time. And you can pack it here, but we already have it packed, so we don't need to worry about it. So what we want to do is have this, the node look at the joints and then look at the geometry and match those together. And that's why we have those name attributes on both of them. So we do capture by attribute, and this should bring us over to this captured state. Now, another thing you can do here, if we reinstate, restart the viewer state, we can select this, joint, and then select this, and it will actually start pairing them together. You can see we can manually select those. So if you didn't have names that were the same, you could go through and just select them like this. And when you start to select them, they will start to gray out, like kind of go transparent like that. That's not what we want to do here because we have those attributes. And you can see when I check that on, they all go transparent and they're all linked together now. And we have this bone capture data now. So we have our weights, which is just going to be 1, and we have the joint that it's the region that it's connected to. So here you can see we have our bone capture attribute. And so that's going to be what we need. So now this is our weighted geometry, and this is going to be our skeleton over here. So if we took this and did a joint deform, and we took this and put this into the first input, and then wired this into the second 2 inputs, and did a rig pose, we can take this and start to animate it. Oh, why is this mad at me? Missing attributes. Oh, sorry. I missed one major step here. I didn't turn that into a skeleton. So that's part of the issue. Okay. I did everything except for the skeleton part of it. So, okay. We have this rig, or the skeleton here. We've got this captured geometry. There's 2 different ways you could go. There's 2 different ways that you could go about doing this. You can use a rig doctor, and this will create some of the attributes that you need. So what we can do is we can initialize the transform and reorient them to the child. And if we scale this up a little bit here, we can see that our joints are now, oriented. By default, they're all like this, all pointing in exactly the same way. But if we reorient them, they reorient based on the hierarchy. So that's good. And you can see now we have our transform stuff and our name. So that's important. And that gets us kind of like where we need to go with that. So we could do that and wire that in, wire this in and this in, and that should make it happy now. Yep. And then if we do a, rig pose, drop that down. Now we should be able to actually animate this. Great. So cool. We've got our little character here, and he's going to be able to move and animate and things like that. However, I think it would be a little bit more interesting to take this and make this into an Apex rig, first of all, and kind of see what we can get into there. And the really nice thing is that this part of it that we've done so far, so like this is our kin effects stuff here, right? So this would just be like standard kin effects stuff. So if we moved this over like that, just put a box around it and just say kin effects. This is kind of the standard stuff. Do that. There we go. All right. Oh, interesting. I did not know that. I didn't know compute transforms. Interesting. Now, Tom, that is very interesting, but I don't, is that not orienting it though? Because my orientations are different here with my transforms. It might be fine. I am not a matrix math whiz. Well, there, anyways. Would that work still? Probably does. Let's see. Yeah, it does still work. Interesting. Okay, cool. That's good to know. You can also use the skeleton SOP as well. You can wire this in, and then that will create a skeleton. The only problem with the skeleton SOP is that it has a stash inside of it, so it stashes the input. And if you update something upstream, that is going to kind of break it and be a little funky. So it won't break it, but it just won't flow through this node naturally. So yeah, maybe in this case, the compute transform is the way to go. So that's cool. Nice. Good to know. Thanks, Tom. Appreciate it. Okay, so let's do a little quick Apex rig here. Shouldn't be too difficult to do, but you know, famous last words. So let's make this up. So what we're gonna do is we're gonna do a packed folder. Pack folder. And the way that this works is we're basically going to create a I see. Okay. Well, let's do that then. Tom is just saying that they're just identity matrices. So let's do that. Let's do the rig doctor. We'll stick with that because that will initialize the transforms and set those all up nicely. I don't know if it'll make that big of a difference, but we'll just go with it. Cool. All right. So what we're going to do, I should also open up this window here. Let's see. Where could I put this? That'll be helpful. I think I'm going to do this. I normally wouldn't do anything too crazy here. Yeah, there we go. Let's do this, and let's change this to be our rig tree. Just make that smaller like that. Sure, something like that. Okay, so what you can see here is when we do this, really once you have any joints like this with names, with point names, with lines and point names, you actually, this rig tree will actually start to read this as like a hierarchy basically. And you've got 0, 1, 2, right? And the body is the root joint there in the middle. And so now we're going and really nothing changes from here. So this rig tree allows us to be able to kind of see what our hierarchy is for this skeleton that we've created. Now another, like the other use for this rig tree is actually to look at and inspect what's happening with these Apex rigs. And so when we start to look at this, it's actually going to switch this over and look at this packed folders structure. And so what we're going to do is we're actually going to wire this in like this in like this, and this in like this. So we've got 3 sources coming in here. We can see our 3 sources have these names. If we had some sort of target folder structure that we wanted to use, we could always wire that in here. But right now, these are just our sources, and we're just going to make up packed folders from this. And what this is actually going to do is we're basically taking each of those inputs and packing them individually. So you can see right now we have two packed geometries, right? You can see them right here. And so we actually want to adjust these a little bit. So what we're going to do is we're going to change these. I'm just going to call this base. You could make up your own name for them, but a lot of the tools within the Apex like auto rig components and things like that, those are all built to look at these names. So that's why I'm going to use them. You can name it your own, whatever you'd like, but I'm just going to use what kind of the base names for them are. And then that way we're not going to have to go through and change a lot of stuff. So we have our base. The first input is going to be our base, and it's going to be a shape. That's our geometry. So that's our base shape. And then the next thing we're going to look at is our skeleton here. So we've got these two skeletons coming in. The first one we're going to name base again. And instead of shape, this is going to be a skeleton. So now we have a base shape and a base skeleton. You can see those here in our rig tree. Base skeleton, base shape. And then we also have one called Rig Doctor, which we want to change that name. And so we're going to have a third input here. You don't have to have this one, but I'm just going to put it in here. It's going to be our guide skeleton. We'll call that guides.skele. And so now we have three geometries that are kind of in this packed folder structure. So this is really very similar to packing geometry in general, where you're packing all of your geometry data to a point, except in this case, we're packing multiple things into multiple, packed geometries, and they can have, different structures and things like that. So that's kind of the difference between a packed folder, is that there can be different ways that this will all have hierarchy and stuff like that, versus just packed geometry is just kind of store it all onto a point, basically. So it's slightly different, but you can kind of conceptually get there in your mind in a similar way to how we've thought of packing things before. It's slightly different, but we just give it these names to kind of, it's almost like the name of these geometries. Okay, so we've got our packed folder here. Now what we can do is start to build our rig logic and build up our rig. So what I'm going to do is I'm going to do an auto rig component. And this is where we're going to start getting into actually building things a little bit further in our kind of Apex tooling, right? This Apex / KinEffects workflow. So we're going to wire this in here, and immediately you're going to see that things have changed a little bit, because now we have this base.rig. And so that's where all the logic is going to live for our character. We're not going to do a whole lot here. It's just going to be FK. There's nothing too fancy about this little character. We could do IK. We could do things like that. But I'm just going to do FK just to make it as simple as possible. So, actually, would it be simpler to do IK? Maybe. All right. Let's see. Let's see if I can do this with an... Hey, Zach, there he is. Position number 1, Mardini. Zach, you don't steal my entry. Look at how good this is. This is going to get you first place. You can't steal this. It's against the law. It's against the rules. I'll blow the whistle if you do. Okay. Let's see here. What would it be? I guess it would just be FBIK. I did this. Well, let's just do this with just FK first, because I did it that way. So somehow I haven't submitted much recently. Well, you apparently got on the board enough to be in first place. That's awesome, man. Okay, so we'll just do the FK transform first. We'll start with that, and then we'll look at the IK side of it. So when we switch over to this, we'll see that not really much has changed. Yeah, the Zacks. There's the Zach meeting of the Zacks, and you both spell your name the same way. It's really funny. I actually, this total side, it's a little tangent here. I actually, at the studio I worked at before, there were 3 of us that worked kind of in the 3D, 2D, 3D animation, motion graphics stuff. And 2 of them were named Zach. They both spelled their names differently, but neither of them spelled it Z-A-K. One was Z-A-C-H and one was Z-A-C-K. So anyways, I just saw those guys. Was it this week? No, it was last week. Gosh, I can't even remember. It was awesome to see them, but we went out for lunch. But anyways, yeah. So Zach, is a very I know a lot of Zachs that do 3D work, so it's kind of funny. Anyways, okay, so we've got our auto rig component. I'm just going to hide this for right now because this really isn't going to change all that much. So let's just hide this. Cool. So we have our auto rig component here now, and this is going to be putting in our FK here. And so what this is doing is this is telling it, hey, we want to put an FK, the ability to do FK on each and every one of these joints in this character. Now we could control this by saying what name we want to look at. So for example, if we wanted to only have this FK on things that were called leg star. Oops, sorry, not capital. Leg star. This should now only give us FK on our legs. You can see now this body joint does not have an FK on it. Okay, thank you. Give me an error. So now these have FK on them. Now you might wonder, hold on a second, where did our skeleton go? We're missing some stuff. Now the reason that where did our geometry go? Because we're only seeing the skeleton. The reason we're seeing that is because we actually haven't put the skin deformation into the rig yet. And so right now we're evaluating the rig and that stuff doesn't exist in there, right? We've only added the FK transform kind of component within the Apex framework. And so that's why we're not seeing that. A Mardini champion is watching. Pressure is on. I didn't even see your comment, Tom. Oh, by the way, Tom and I have been talking, and I think we're going to do some introduction to Apex stuff, at least a stream together. And I'm going to have him on as a guest because he is very smart with Apex and can do some really fun stuff. It's not going to actually be Apex rigging. We're going to actually look at the actual straightforward like basics of Apex and talk about that and kind of build up from that. So this is actually pretty complex Apex stuff, but it's packaged a little bit more digestible. So there's a lot going on inside of these auto rigs and stuff like that, but we'll talk a little bit more about the actual nuts and bolts in the future. But that's something that we've been chatting about. So anyways, cool. Okay. So the reason for this, like I said, is that we haven't given the skin deform in here yet. And so what we're going to do is let's do another auto rig component. And I'm just going to name this one actually FK. And now if we come down here and change this component to be bone deform, that is going to be, that's going to now add that in for the skin to actually be deformed along with the joints. So now if we take this and move it, we'll see that these are actually going to move around. So that's cool. Like that's, I think, pretty exciting. We've already got some rig stuff going on here. And let's see here. We're going to just say bone deform. Okay. And so when we look at these here, we can see that a lot of these different things that it's looking for is like, okay, what's our skeleton that we're going to be looking at? All right, we're going to be looking at the guide skeleton. What are we going to be outputting it onto? We're going to be outputting it onto the base skeleton. What kind of controls are we going to be looking at? This isn't super straightforward, but what we can actually look at here is if we did, so this star here basically means that we're promoting this our promote group basically means that we're giving you access to the rotation controls on each of these points. If we did T promote group like this, that would also allow you to be able to transform it. So, and then S obviously would be scale as well. So that is something that's a little bit further inside of the actual Apex graphs that are being created. We're building Apex graphs right now. It's kind of like how in Solaris you're building USD, but you don't have to like actually see the USD all the time. You can see the Apex graphs that are being built, under the hood here, but right now we haven't looked at the graph at all. We just know that we're making these pack folders and things. So anyways, yeah, so you can adjust how these will work and things like that. Here, when we look at the bone deform, you can see here we have our rest geometry, we have our rest skeleton, and our output skeleton. Oh, also the animated skeleton. And that's coming at this point to transform geo. So that's the geometry that would be from our animated skeleton. And so this is basically just saying that the point transform information is what's driving the animation. So, so yeah, there's a lot of other things, that there's a lot of things happening inside of these, but this gives us the ability to control how we're building that rig logic, right? And again, this is all going into, okay, thank you. This is all going into this base rig right here, packed geometry. So if let's see here, I think what we need to do is we need to add this to a, sorry. Which one is it? It is Apex Scene Add Character. So now we actually have a character being added into our scene. And so now this is going to change some stuff as well. Now we're starting to see this hierarchy, right? And what we could do here is we could have multiple characters, right? So this is actually going to be the character's name. And so what we could do here is just say simple robot. So that's now our simple robot character. There's our scene graph. And that lives inside of, so this hierarchy lives inside of there. So this is how we can start to see multiple characters added into our scene. And then if we wanted to, do, scene animate, now this is where our animation would live inside of here, and we could start to do all of our animation type stuff and, whatever. I don't know. I'm not an animator, but we'll just do some silly little posing here or something. I don't know. We could do all of our keyframes and things like that in here. And those would start to live in here. And I believe, let's see here. The keyframe there, and then go a little bit further. Just see if, I think this should work. Mm, no. Interesting. How do I do that? That must be it. I have to do that, I guess, maybe? Yeah, that's probably it. So I do this and then, yep, there we go. Why that was, I'm sure there's a reason. I'm sure I could have selected that differently, but that's okay. And then we can go through like so. Oops. Move that weird in a weird backwards state. There we go. Pose hit K. Thank you. That is not up in this little thing here. That's interesting. Yeah, cool. Okay. Anyways, little animation, nothing crazy. I think if we look at this too, we'll see that they're maybe not. Where does that live? That must live in the scene graph, maybe. Those. Oh, there it is. It's like that should live somewhere. There it is. So now we have animation data here that lives in there as well. So this is now building our scene. You can also enable auto keying. Right. Cool. Okay. Nice. Okay. Anyways, that's not what I'm doing here. I'm not an animator. This would be silly to even see me animate. So, okay, cool. So that's all well and good. I'm just going to close that. I'm just going to delete this. We don't need this right now. Okay, thank you. And great. So there's our character. I'm kind of curious if I can add IK to this. That would be interesting. I think it would be this FBIK. I think. All right. So yeah, I'd probably have to set up a bunch more things here with some tags and stuff like that. Yeah. Hey, hi Goldfarb. Hope San Francisco's going well. Oh, smooth IK is what you used. I see. Oh right, I didn't have to delete that. It's the same node. Bum, bum, bum. Smooth IK. Yes. Cool. Okay. So what we could do. Yeah, I think this would be fine. Have a meeting in 10 minutes. Have fun. Bye, Goldfarb. I think you're actually meeting with somebody from Rochester, so that's kind of exciting. Have a good time, or maybe you already did. Anyways. Oh, multi IK will do all at once. Okay, cool. Nice. Okay. Okay, so what I could do here, I think, let's see. The segments are going to be here. I'm just going to open this up. We should be able to see leg, star. Okay, great. So let's give it a try. Okay, let's see. Attribute adjust array. Can wire that in here like so. Close this up. So, yep, so this is going to make tags. So we can do this and say how do we do this again? Oh, that's right. I can look at that. I downloaded a thing because I wanted to look at something a little bit later, and we are going to just open this now. So I downloaded one of the workflow things to show how to kind of move back and forth between KineFX and Apex, which I think one of the Zachs was messing around with and had some cool stuff on our Discord server. So that was kind of what made me think about this a little bit. Like, oh yeah, I could maybe do that and see what I could get into. So I am going to open that, and then in downloads, there we go. Cool. All right, we'll start that up. So pretty sure. Are there tags in this one? Maybe. We'll see. We will see. Give it a second to load that up. Yeah, so because this is all being saved in those packed geometries, and then when we do the scene animate, it basically, or a scene invoke, it basically executes all of that stuff at, all of the animations and things like that in our scene, so that you can then see it all come back. Yeah, that's cool. Apex went from an annoying thing I had to learn to a fun puzzle. Yeah, exactly. It is. It's a little like, once you kind of get past some of the base concepts, I feel like it starts to make a bit more sense and things will click a little bit faster. I think when you try to take it in as this like, just like drinking from the fire hose kind of thing, it's a little much. But if you take it slowly, like at the base core concepts, and go from there, I think you can get to some kind of cool stuff. And I've done some of this stuff before. I'm just trying to kind of push myself a little further to see if I can do some procedural animation in here to make a little crawly character. Are we opening up here? Hello? There we go. All right. Let's take a look at this. So this is from the content library. Let's see. Unfortunately, we have a little black error with the yes, this doesn't actually have the tags on it. So let me just go back here, and I'm going to download content library. I'm going to download one of the newer ones that does have that, which would be this one. Take a look at this one as well. Open that one up. I'll just open that. Particularly large scenes, so I'm not too worried about them. All right. So this is actually the workflow to get to basically pop the controls out and then modify them and then update them back into the Apex world and add those back into our scene graph. So this is sort of the idea of that you can break these things out. So in this case, we're taking Electra, right? Okay, thank you. So this is the... This is the other one here. And so I just wanted to look at how these tags were done. Okay, I see. For some reason, this just wasn't clicking in my head. It's the name of the joints, it looks like here. So this is the toucan. Let's look at the biped. Yeah, just the name of the points. Got it. Anyways, those are the tags on the guide skeleton that we're going to use. Anyways, cool. So in this one here, what we're looking at is we're actually taking Electra in this case. We're actually adding her into the scene. So we do the chicken and then we add Electra. I don't know why those, I guess the textures must have not. I'm just going to turn this off maybe. It's a little better. Not sure why the textures aren't working, but I'm sure there's a reason for it, but there we are. Anyways, so there's a chicken, there's Electra, and then we split things out, like getting Electra's information from it. We get out the controls, and then we get our skeleton here. We do some things like rig posing it, and this is going to be our skeleton, right? That's going to be from our, our that we want to retarget, and then we do the retargeting workflow where we map the points, select the transforms, and we offset some stuff with it. It looks like here, and so this we're just basically copying the transforms onto it from there. Now this, I think we're actually doing some, we're stabilizing some joints, messing with the animation, doing things like that. So that's a little bit different. And then we basically update the controls, turn the animation into a motion clip like so, and then add that animation back in. And then we have our scene animate. Now that won't show up until we get all the way down here. No, won't. Yes, it'll show up there. So there's our scene animate. And then our scene invoke down at the very bottom here will have all that stuff running for us. So, okay. So let's get into this and set up those tags and see if we can't get some fun stuff happening here. All right, I'm going to minimize this one. Let me just look at this again and see what it is that this is building for us. We've got our tags here. Okay, just an array. Cool. We could actually probably build that ourselves without even having to have because we have the names of the joints and things like that. So we could almost do that ourselves. Yeah, actually know what we could do. So we could do this attribute adjust array. Sorry, we could do that in our, we don't need to do it there actually. We could go up a little bit further and add our tags array in here because we could do that from our skeleton here. So let's do that. So the things that we need to set are, let's look here. Okay, and then all right. The pole vector is going to be interesting. We don't have that. We'll have to think about that. IK root, IK tip. And that should do it. If we have the segment set to leg. Okay, I think that makes sense. Because this is a tag it's looking for, and these are the tags that it's looking for each of these. That's a tag. Oh no, this is setting one, sorry. Yeah, that's easy enough. We can just do those over here. So if we set this attribute adjust array, if we put this here, we should be able to do this and add, should just be able to add all of them, right? Point, yep, there we go. Select all of them. Add tag, and then we'll call those leg. And then if we come down here, we should see tags have leg on those, and that's great. Hmm. Oh, interesting. Oh boy, that didn't exactly work. Um. Hmm. Sorry. Let me look at this here. Let me go back over here. Multi IK leg and arm. So we look at this and find the. Yeah, it shouldn't really matter there because the names are the same. Let's just look at this, see if there's anything changed in here that I missed. Guide scale settings. That's working. Okay, interesting. Well, oh, maybe that's what it is. Sorry. It does need to have some sort of a number to it because it can't just all be the same because that's all this thinks it's all the same segment. Uh, all right. Just have to think about that. We did this procedurally. We could just do, let's get rid of this. We should just be able to do this here. So let's do this. Let's add an array here. I think this should be easy enough to do. So we'll just do a string array at tags was the name, I think. Yes, I think so. Yeah, tags. Okay, so we'll call this um, do this with set. I think I can. Yeah, I think that'll work. Um, yeah. Okay. So I need to set this up as a string ahead of time. So let's do this. String name. Oh, thanks, Tom. Thank you, sir. All right, that seems to work. Let's see here. What is that going to do for us? Hey, that might have done something. Let's see here. I mean, it's at least working. At least not breaking, I should say. That's not doing that. Oh, yeah. Hey, that's kind of working. Cool. Um, is there a way to set a joint for the pole vector? I wonder. That's cool though. That's definitely working. Um, all right. So for this, actually, if I turn that off, oh no, I'd not bypass it, but just if I did this, that won't have. Okay. Or FK. Interesting. I don't know why that's breaking it. Anyways, okay. So we have these set up. Question is, oh, and then a pelvis? I want a pelvis. Interesting. There's a spider rig on the content library. Thank you. Thank you, Tom. I know. I know. Thank you. I think there's another thing that I would want to do here, which would be what was this one called? Transform driver, I want to say. This would be body. I think. Like that. Oh, it's lowercase. That's my bad. All right, let's try that again. Reset that. Clean, reset, body. Fun. That's weird though. That isn't. I think that's actually transforming that. It's interesting. Yeah, I didn't like that. Okay. Hmm. Interesting. I think if we do that, that's good enough. Oh yeah, that's what I should do. Sorry. Just remembering here. So I just changed this over to undo here, folks. There we go. So leg, we'll keep that. And then we'll just do rig component. We'll do another one of those. And we can do, maybe that would actually make more sense. And we'll just do this with body. There we go. And for this, we're going to do the transform as well. Okay, so then if we do scene animate down here, we can actually be able to control this a little bit. I want those like turned like 90 degrees. Okay, cool. Cool. We'll just do reset all here. All right, so let's see if we can't get something going on with those joints. Let's see. All right, so what we need to do is we're basically going to do this where we get the control skeleton here. So we'll do a control extract. And then well, we could do, let's see here. What is this? This is making a full path. Okay, so just trying to think of what would make the most sense here to do. I think we'll probably do something sort of like this. So let's do that. So we can take this here. Sorry, selecting too many things. So let's do a apex control extract. So we're going to wire that in there. Bring this down. We won't need this for a little bit here. Actually, we might not need it at all. That's fine. So we're going to extract from the folder. And can we do this? Let's see. I think that would be what we'd want to take out, the simple robot character. Let's double check here. Oh, okay. We want to take the base rig out of it. That's what we want. All right, so we'll do this simple robot character base rig. You're actually seeing the graph there, a little scary. Geometry is graph is geometry. Okay, so this should be our control skeleton here. Sure enough, there it is. Cool. Oh, interesting. Are those our pole vectors here? Yes, they are. Interesting. So let's select these here and just see what we have. Joints. Take the IK targets, I think. Move those. Okay. Just trying to think here. We do a rig fop. Is that what we would do? Let's see. Set point transforms. Just see if I can. That should work. That would get us our point transforms. Name. Let's see. Can we do this? Let's do it. Set point transform. Oh, this actually might make more sense because this is only going to do one. This should do multiple. This actually might do it. We do at name equals leg star. Oh, sorry. Underscore IK do it, I think. And then I'd have to do something in between here. They're going to be arrays. Well, why don't I just try this with one first, see if I can get it to work. Get point transform. Say get that over. Step point transform. I think what I could do is I just want to put like something really simple, like a sine movement on one of these legs and see what happens here. So is there an extract transform? Is that what it is? Yes. We take this. Give us our translation. If we just do a sine, this work? Really? Let's do this. Frame 2° to radians. Give this a shot. See what happens here. So we're doing a degree to radians. Frame. Cool. We'll just take a sine off of that. Take the translation. Maybe just float. Axis around Z. So we'll just add this sine into the Z. Then just do that. Whoa, getting a weird flash there. That's strange. Sorry about that. Sorry if that's distracting. All right, let's do that. Float vector. There we go. Then we'll do make transform. It's gonna go up here. This, I think. I'm just guessing here, so hopefully this will work. Ah. Aha, okay. We're getting somewhere. Things are happening. Don't know if this will work or not, but it'll at least give us an idea if this is viable. All right, let's scale this. Let's do another multiply. Constant here. Do this times 4 maybe. Okay, cool. And could we rotate that? Sure, we could. Yeah, let's do rotate. Here. Axis would be uh, so we did this. It's in radians. Um, well, I guess what I could probably do is do the position here. Could I do a subtract constant from that? I have to do a subtract. Right? I think I could do this and then just subtract a constant here. Vector. No. What am I? I'm missing something here. Super simple. The axis should be. Hmm. Oh, well, let's just leave that for right now. Not really sure. Oh, I know what I could do. I could do this, and then I could come up here, and I could do a rig pose just on that. Just make my life a little easier. Probably grab that one. There, 90 degrees. Cool. All right. So that is the control extract. Then we want to do an update, update arms, then a motion clip. Okay. Okay. And then we want to do a motion clip. Here. What's the next thing we did? Add animation. I see. Get animation here from. Guess it doesn't really matter. We don't have animation. Add. Animation. Oh, sorry. I see. From motion clip. There we go. Channel primitives from motion clip is what we need. Let's throw it on a scene animate up here. Just gonna move. Oops. Got snapping on. Gonna move this up, perhaps something like that. And that's our animate there. Just gonna make this a little neater. Right, so that's gonna unpack the folder. Got it, got it. Oh no. Darn it. We're going along so well there. Shoot. We're getting close. We're getting close. Well, if you stuck around with me for this long, appreciate it. I know it's been a little bit of a more experimental one, but yeah, we're getting somewhere. Okay. So I think what we're going to need to do here is we're going to need to get our animation. Yep. So from here, we're making our animation, and then down here, we're going to be unpacking that animation folder. So there's our rig tree, there's our animation. We're going to hit accept, then we're going to hit star here. And that is going to unpack our animation channels. That is going to be some channel primitives for us to use. So that's good. Then we are going to update this and update our channel primitives. And now here we should have channel primitives. We can put those in like this and this. Here, stalking in the shadows. Hi, Epoxia. Welcome. Okay, so just make sure that I'm making some sense of this here. I'm just going to close this. Done enough with this. All right, so let me just make sure I'm setting this up right. Okay. Let me just open up a new floating panel with that and just look at the rig tree, because this is helpful to make sure what we're looking at here. So in this case, we've got the chicken character here. Let's see here at this point, we have chicken character base, Electra character base. Down here, what do we have? Okay. Base.rig. Okay. I think that makes sense. Let's come back over here and we'll just say dot that, and then there's that. And then down here we have a scene invoke. Let's see if that'll work for us. No. I mean, I probably did something wrong, but let's just see. Oh, I see. We're only grabbing one. Interesting. So they're only updating the root in that scenario. I can make sure that we're not getting any other stuff created here. Okay. Actually, that's interesting. I am just going to keyframe here. Yeah, nothing's happening here, which is a little odd. I feel like we should see something there. Maybe not. Maybe not. Hide the other stuff here, just to make sure I'm not missing anything. All right, let's see if just see if this is putting it back into a reasonable spot here. Let's see if that does anything here. If we keyframe all of the do anything for us here. Ooh, yeah, okay. We have more channel primitives there. 374. Okay. Hey. Something's happening here. Why is the invoke not working? That's weird. Not sure why the scene invoke is not working. Oh, right. Right. So it's probably that. Animation target. Oh, okay. Channel prims are invisible in the viewport. Got it. Cool. Okay. Well, this scene invoke, I don't even know how that works, but I'd have to look into that a little bit. But here we go. We've got procedural animation going on here. Now, why did this not get passed through? Oh, I know why. Because that got stuck in here. I see. So what we can do is say, we could say that the root control here is the group. These are the, yes. So if we did a, press the output shapes button. I see. Thank you. Let's see here. I would have to, no, that's the wrong thing. Sorry. I just want to see the rig again. So just leg 0. Yep, would be fine. So I think I could do that. I could just do leg star, and I think that would give me pretty much everything. If I looked at this, yep, and now we don't have the body there. That probably put us in there. No. No, whatever. That's interesting. We have controls for all of those. Interesting. It's weird that it's updating that one, but regardless, okay. Yeah. Okay. Well, anyways, it looks like we got some animation in there. So we could certainly go a little further with that and create some more animation. Now, why that was causing that issue, I am not 100% sure. But we did some Apex today, so that's fun. Yeah, we'll continue to talk more about Apex in a future installment, but we'll get into a little bit more of the nitty gritty and actually look at even just like what Apex can do with geometry and manipulations and things like that. So, let's just find that file real quick here. Temp. Oh, cool. That's fantastic. That's just great. Yay. Well, everybody, that might be the end of this because I have a file that is not wanting to open for me. So let's see if we can't get somewhere with this. But it seems to be a bit angry at me. Probably did something dumb. Let's see. I'll set this to manual. Here. Be like that sometimes. Yes, it does. Maybe that'll work. All All right, let's just do an auto update here and see what happens. Okay. Things are going okay. Do I dare? Overlapped keys. Okay. Well, I will try to sort that out after the fact here. Not 100% sure what's going on there, but yes, we will figure that. I'll figure that out and see if I can't come up with something a little bit there. But anyways, hopefully I had fun seeing a little bit of some more Apex rigging stuff, doing some procedural animation in there and things like that. You know, it's a start. It's you know, we're learning some things here. And yeah, I'll put the file up online once I can get it to not crash when you open it. And we'll see kind of if I can get anything going with that. But thank you all so much for joining. Thank you for being here this evening. Thanks to Tom in the chat for giving me always my Apex guy. And we'll have him on the stream and actually chatting in real life. And yeah, have some actual real professional Apex stuff on the stream. I've also been talking to a couple other folks for some guests. It's been way too long since I've done that. And yeah, that'll be some of the stuff for this year. Get some more guests on here, so I don't soon have to listen to me ramble on forever. But yeah, we have some fun ideas. So hopefully we'll have some good streams with that. But thanks everybody for joining. Thank you for being here. And yeah, I'll see you all next time. Good luck if you're out there doing some Mardini, and we'll see you next week. Bye everybody. Have a good one. See ya.